Hi, everybody. I wanted to give you a quick introduction to the ideal gas law and walk you through how to solve a couple problems related to it. Actually, I'm just going to solve one problem, but hopefully that one problem will give you an idea of how to do it. So before we jump in on actually solving a problem, let's talk about the ideal gas law. The ideal gas law, as you can see written over here in this corner, is PV is equal to nRT. Now, P stands for pressure, and V stands for volume. The N right here stands for number of moles, R stands for a gas constant, and T stands for temperature. And what this law is telling us is how pressure, volume, number of moles, and temperature are all related to each other when it comes to a gas. And this is very useful because an equation like this can help you to figure out any of these different variables in different situations. And so this is really useful to chemists because chemists deal with gases all the time, but there's many industries out there that deal with gases as well. And so this is a really important idea to be able to understand. Let's go ahead and solve this equation for the different variables within it. So, for example, if we wanted to solve for pressure, we have PV equals nRT. If we want to solve for P, we need to get rid of the V, and so we would divide both sides by V, and we would be left with P is equal to nRT over V. We can do the exact same process to solve for V instead of solving for P. And if we do that, we would be left with V is equal to nRT over P. So in this way, now if a question asks us what's the pressure, we know that we can use these variables to solve for it. And also if it asks what's the volume, we can use these variables to solve for it. Let's go ahead and solve for the last two that we're going to need to deal with. And so if we had PV is equal to nRT, if we want to solve for N, or number of moles, we would go ahead and divide both sides by RT because we want to get N by itself. And if we do that, and we do that math out, we're going to be left with N is equal to PV divided by RT. And then if we wanted to lastly solve for temperature, we can do the exact same process. We would divide both sides by, in this situation, Rn, and we would be left with temperature is equal to PV divided by nR. So now what you have here is I've went ahead and showed you how you can use the ideal gas law to solve for different variables that a question might ask you for. So without further ado, let's go ahead and jump into an actual question that we can use the ideal gas law to solve. This question here deals with a hyperbaric chamber. It says a single patient hyperbaric chamber has a volume of 640 liters. At a temperature of 24 degrees Celsius, how many grams of oxygen gas are needed to give a pressure of 1.6 atm? So how would we go about solving this? So first of all, a hyperbaric chamber is something used in the medical field to help increase the amount of oxygen a person breathes. And so a person would lay inside of this chamber and they would pressurize the chamber with oxygen gas, and the person would be able to breathe pure oxygen at a higher level, and this allows for treatment of many different illnesses and is helpful for many different things medically. So in the question, what is it asking us to find? If we look here, it's asking us how many grams of oxygen gas. Now, if we think about the ideal gas law, nothing in here is in grams, but one thing that is in here is number of moles. And if we know number of moles, we can then convert to grams. And so we're going to use the ideal gas law to solve for number of moles. And as I showed you over here, to solve for number of moles, that is going to be equal to pressure times volume divided by the gas constant times temperature. First thing in this equation that we're going to need is pressure. And so in the question, it gives us a pressure that we want, which is 1.6 atm. 1.6 atm times a volume. In the question, it gives us 640 liters. And the next thing that we need is the gas constant, which is going to be, and this is just a constant, it's something that that you can just look up, but it is 0.0821 liters atm per mole. And then the last thing that we're going to need is temperature. And in the question, it tells us that the temperature is going to be 24 degrees Celsius. But if you look up here, with the ideal gas law, temperature always needs to be in degrees Kelvin. And so to convert between 24 degrees Celsius to Kelvin, we need to add 273. And when we do that math, we come out with 297 degrees Kelvin. So we can go ahead and put that in here. 297 degrees Kelvin. Now we can go ahead and solve this equation here. And when we do that, we come out with 42 moles of O2. So we've used the ideal gas law to figure out how many moles of O2 we would need to put into the hyperbaric chamber, but that's not what we need. We need the number of grams of oxygen gas to put into the chamber. So we can then go ahead and convert moles to grams. 42.0 moles of O2. To convert that to grams, we would use the molar mass on the periodic table, where 1 mole is going to be equal to, remember that oxygen gas is diatomic, meaning there's 2 oxygens for each molecule. And if you look on the periodic table, you will see that 1 oxygen is about 16 grams per mole. And so 1 molecule of O2 would then be 32.0 grams per 1 mole. And so if you go ahead and do this out, you'll see that moles cancel, and then you can multiply 42.0 times 32.0, and we are going to come out with 1,344 grams of oxygen gas. Now remember that in the question, if you notice here, the lowest number of sig figs that we were given were 2, and so we need to round this number to 2 sig figs, and so our final answer would be 1,300 grams of O2. And that's how many grams of oxygen gas you would need to put into the hyperbaric chamber to result in a pressure of 1.6 atm, which is 1.6 times the pressure found at sea level. And so I hope that this tutorial was a little bit helpful in showing you how to use the ideal gas law to solve for different variables, and then how to use those different equations to be able to solve problems that are given to you.